All right, guys, there we got variation and applications. Variation and applications. I'm trying to make this pretty quick. All right, direct variation is the first type we're going to see. And just give you a quick example here. So suppose a veterinary assistant earns $10 an hour. In 1 hour, $10 earned, 2 hours, $20 earned, in 3 hours, $30 earned, and so on. That's just an example of direct variation. And for every hour worked, you get much more money. So as the hours worked go up, the more money goes up. And that's how direct variation works. And there's a variation constant. For example, if you take the problem up here or the example up here, 10 to 1, $20 for 2, 30 for 3, 40 for 4, the variation constant would be 10, because if you divide those, you get 10 every time. So that's called the variation constant. All right, if a situation gives rise to a linear function like this, y equals kx, k is the positive constant, constant k, we have a direct variation. Last time it was 10, or that y varies directly as x, y is directly proportional. These are all the ways you may see it written. Number k is called the variation constant. And that's our equation up here, y equals kx. Don't forget that y equals kx. So if y equals kx, think about this. If they ask you for the variation constant, which they're going to do, you just divide both sides by x. That's how you find the constant. Like on the last slide, I did 20 divided by 2, 30 divided by 3 to get that constant. All right, let's try one here. Find the variation constant and equation of variation in which y varies directly as x when y is 32 and x is 2. Sorry about that. So your equation will look like this. Y equals kx. So it says y is 32 when x is 2. So if I divide both sides by 2, there's my variation constant. And your equation of variation will be y equals 16x. So basically, your y is always going to be 16 times bigger than your x. And that's all they really want you to do there. All right, the other way is inverse variation. Inverse variation is kind of the opposite. Suppose a bus is traveling at a distance of 20 miles at a speed of 5 miles per hour. It's going to take them 4 hours. If you're going 10 miles an hour, it's going to take 2 hours. If you're going to go 20 miles per hour, it's only going to take 1 hour. So the greater the speed, the less amount of hours. So it's basically as one's going up, the other one's going down. And so 5 times 4 is 20, 10 times 2. Remember last time I was dividing, this time I'm multiplying. 20 will be your constant variation or your variation constant. Let's look at the official definition here. Inverse variation is not y equals kx, but y equals k over x. Y equals k over x, where k is the positive constant. We say it this way. It's inverse variation, or y varies inversely as x, or is inversely proportional to x. K is the variation constant, or constant of proportionality. So our equation, y equals k over x. If we're just looking for k, what our constant is, we would multiply both sides of x, and k is xy. And if k is constant, think about it. As x goes up, y must come down for the constant to be the same. Okay, let's try one of these. Find the variation constant and an equation of variation in which y varies inversely as x. So that means this, y equals k over x when y is 16 and x is 0.3. So I'm going to put 0.3. I missed the point. I put it in the wrong spot right there. Let me erase that. So I'm just going to cross multiply right there, and I would get 4.8. That would be my constant. Says find the variation constant. There it is. So that means this, y equals 4.8 over x. That would be my equation. So that's the two things we want you to find. Find the variation constant and the equation of variation. And there it is. Okay, last example here. The number of centimeters of water produced from melting snow varies directly. Okay, because it varies directly, we're using this, y equals kx, as s, the number of centimeters of snow. Meteorologists have found that under certain conditions, 150 centimeters of snow, I should have known I used y and k. Let's do this. Water varies directly as snow. So I'm looking at that. Meteorologists found that under certain conditions, 150 centimeters of snow, which is over here, melt to 16.8 centimeters of water. To how many centimeters will 200 do? So what I'm going to do first, I'm going to find my k. Didn't do a very good job there. So I'm going to divide both sides by 150. So I'm about to punch in my calculator. 16 divided by 8. Sorry, 16.8. Having a hard time today. 16.8 divided by 150, which means my variation would be my constant would be 0.112. So this says, how about with 200 centimeters of snow? So I'm going to say, okay, so water would be 0.112 times how much snow there was, which was 200 centimeters. So look at how much water that would produce. Just going to multiply that, 200 times 0.112, and I would get 22.4 centimeters. And that's how much water produced. So first thing I do is find my K, find your K, come up here, use it to solve your equation. And that's when you do word problems tomorrow, that's exactly what you're going to do pretty much every step. You do have to know if it's inverse or direct though. All right? Sounds good. I'll see you tomorrow. We'll work on these things. Look forward to it. See you. Bye.